Okay, so we've given people a few minutes to jump on, so I shall begin. Welcome. Thank you very much for taking the time to join me here. My name is Eddie Thompson. I am a solution engineer here at Sumo Logic. I am being joined today by my boss, Ryan, who is going to be answering the questions live in our Q&A function. So, Kubernetes and Sumo Logic. This is the topic of the day, the topic of the hour, and what I shall be diving into. First of all, a little bit about Sumo. So, we are the industry's first and only continuous intelligence platform. And what does that mean? Well, it means we are able to take in your logs, take in your metrics, take in your security events, and apply some different lenses to that data. Being able to provide you with things like operational intelligence, security intelligence, business intelligence, and even global intelligence. Global intelligence being our machine learning that we apply to that data for you. A little bit on that later. First of all, let's go into a little bit of detail, a little bit of the history about what Kubernetes is and how it started. So Kubernetes is a container orchestration platform. So it was developed by Google and it was open sourced, and is now managed by the Cloud Native Computing Foundation, which is a spin-off of the Linux Foundation. Now, it works upon what we call desired state management. So you've got declarative configuration. It means you tell Kubernetes what you would like to achieve. That is, how many of something you would like, what level of redundancy you would like, and then you basically let it go off and do its own thing. So we don't need to specify which host something is going to reside on. We let the orchestrator make these decisions to best utilize and optimize the usage of the hardware that you have, or the virtual hardware that you have. So everything in Kubernetes is by design ephemeral. So that is what enables it to have this elastic scalability. If it needs to, it can spin up more resources or reduce the amount of resources, because adding a pod or removing a pod, it's ephemeral by design. It's not going to affect the state of the application. And the other thing is it runs anywhere. So be that private, public cloud, or bare metal. So the Cloud Native Computing Foundation, it's part of the Linux Foundation. So it's a non-profit organization, and it is the governance structure for a whole bunch of different open source computing projects, which run all sorts of applications and underpin all sorts of applications that we're running on the internet. So Sumo Logic is a member. We do contribute our code that we're working on back to the projects. So we're a silver member. You can see there that you've got members from the major cloud providers, network providers, hardware providers, telcos. It's pretty broad. It's one of those things that everyone's involved with and everyone is using. So a little bit of key terminology for you. This is some of the language which is important to understand when we're discussing Kubernetes. This is part of the mental model that people have, and it's important to understand how our solution fits into this. So a little bit dry, but we'll run through it. So a cluster. A cluster is the main grouping for a Kubernetes deployment. It consists of a master node and a number of worker nodes. So the master contains the API server and things like that, the scheduler. And the worker nodes have the pods and the containers which are actually running the application and service code that you're actually deploying. A node is a worker machine in Kubernetes. So this is analogous to a server or a VM. Could be either, but it's the compute capacity that you have to run your services. A pod is the smallest and simplest deployable object within Kubernetes. A pod contains one or more containers. You cannot deploy a container within Kubernetes. You can only deploy a pod which contains a Kubernetes. Pods are generally managed by a deployment, which I'll get to on my next slide. And the container is the deployed image that you have from your code. So that contains your software that you're running, like a web server or a microservice, and any dependencies that it requires. That's all bundled together and deployed as part of that pod. And the main thing that's important about this is it sort of decouples the requirements to have software installed on the node specifically. So you know that anything that is required for that software to run other than the operating system has been packaged up and exists with it. So that's one of the key things when it comes to deploying across different clouds and different environments. You know that everything it requires comes with that container. Deployment. So as I mentioned, pods are generally deployed via a deployment. What is the reason for this? It is all about simplifying the management. So if you have a pod and you make a change to it, that's fine. If you have 16 pods and you wish to make a change to all 16, you don't want to make that change 16 times. You want to make that change once to the deployment, which manages that set of pods. It also means that you can have related pods deployed and configured within a single management set. So you might want to have some related services of different pods deployed together as a set. And once again, Kubernetes works with what we call desired state management. So the deployment, we're setting out our desired state for that deployment. Then the cluster manager is pushing out that deployment to the nodes. Namespace. Namespace is a really important one. This is the abstraction or the logical grouping that we use to divide up a Kubernetes cluster. If you're familiar with namespaces within a DNS or within a programming language, it's the same function. It means that names must be unique within a namespace, but they can overlap between namespaces, which is really useful when you've got things like a development environment, a staging environment, a production environment. You can use the same names overlapping between these environments and not run into issues of names clashing and having to rewrite with things with scripts. Very, very useful, but it's also a common logical demarcation for people to use for different teams, different business units, so they can share the same set of resources, but have no concerns that they're going to be interfering with what's going on for the other users within the environment. And finally, the last piece of key terminology I have for you is a service. And this is the really important one, because the service is what exposes the running application you have as a network service to your network or the internet or the broader world. So it's generally really important for the developers who are using your Kubernetes deployment. They might not really care about how Kubernetes functions day to day. What they care about is the service that they are putting out to the world. So they've got a payment service, a user service, a map service. That's what they're deploying. That's what they really care about. So our Kubernetes app, it's all about providing you visibility. So both into the worker nodes and their application logs, but also the key metrics that you're using to monitor and troubleshoot container health, replication, load balancing, pod state. The other thing we do is we use Falco to monitor and detect security anomalies at that sort of kernel level. So also providing you deep security insights into your Kubernetes environment. So that's enough of the slides, and I'll jump over to a live deployment and you can see it in action. So this is our Kubernetes Explorer. And the first thing you'll notice here is we're looking at a cluster overview dashboard. This provides us with a high-level view of what's going on in our cluster. And I've purposefully started at what we call here the Kubernetes node view. And this is how we would traditionally have viewed Kubernetes resources. So specifically, this is an infrastructure-based view. So I've got my cluster here. That's the name of my cluster. And I can see it here, it's tagged as a cluster. I can expand this. This is all dynamically generated. I'll go into that a little bit later, some of the more specific details on how this is generated, but we can see here that I have a collection of nodes. This is compute that I have running on EC2 instances on Amazon, US West, you can see there. And if I expand a particular node, what you can see is the pods that are contained within that node, but you can also see that up the top here, my dashboard name has changed. Everything that we do here within the Explore view is contextual. So as I've clicked on a node, it said, okay, I'm going to show you a contextual dashboard for this. And you can see here that it's also building out the selection tree that I've made as these filters at the top here. So that's all dynamic as well. So we can see here that there is an overview, and we can see things like CPU utilization, memory utilization, resource utilization. This is very hardware utilization specific type information. Whereas in general, your users, what they're caring about more is actually what's going on with their stuff, which is the pods. And the issue that we've had with a lot of traditional operational tooling and Kubernetes is that it has this infrastructure-centric view. And so I've got a bunch of pods here, but these are all ephemeral. So these come and go as they're being spin up and spun down. But the issue that I have is I've got a list here, but it's alphabetical, and that's about the most organization that I get from here. So where things get really powerful, and what Sumo Logic and its metadata enrichment enables you to do is pivot through these different lenses. So I've just clicked on the menu here under Explore By, and you can see here that I can actually swap between node, but also deployment, namespace, and service. So you can see why I gave a little bit of attention to the terminology before. But say I want to view my cluster in a more logical sense. I can go to the namespace view. So where I have, now I've gone to the namespace view, I've still got the same cluster. I've got my cluster overview dashboard here, and once again, I've still got these network CPU memory type statistics, but this is providing me some other information too. Things like errors by namespace, what security rules I've had triggered, and also some honeycomb stats of my different namespaces and any containers or pods which may be having some issues. Where things change is as I expand my explore tree here, rather than getting a list of servers, I now have a much more logical order to things. I have some namespaces that I can view. So I might want to have a look at my loggen namespace, prod loggen, and I can expand this. And once again, my dashboard has changed contextually. So I've actually got a whole list of dashboards that I can view within here, but it's told me one, shown me one that is relevant to the tree, the portion of the tree that I'm currently in. So what I can do now is have a look at what this overview is providing me. So the number of pods I have running, what I have in a failure state, the number of errors I have by pods. So I can see I've got some problems with Mongo and PagerDuty, and then the containers that have errors as well. And then I've got it broken out to the pods that I have running in these specific deployments. The green ones, they don't have any issues. The red ones, I can see that their state is going up and down here, and I've got two that have an issue. But the one that sort of jumps out to me is the carbon black pod that I have here. And the reason it jumps out to me is that it's not showing up in this list of errors. So I'm going to investigate this. Now, I could browse to the pod that I see here, but I can also click on the pod and I get some contextual options. So if I wanted to investigate the related logs, I can do that. It's shown me some recommended dashboards that I can use, but it's also given me the ability to drill down specifically to this pod. So I'll select that. And once again, we can see that I've progressed down the tree in the navigation and it's added to my filter at the top here. And the dashboard has changed to something that is relevant to the level that I'm on. So I can see that this pod is in a crash loop backoff state and it has restarted 33 odd thousand times in the last 15 minutes. So it definitely has an issue. Pod events, these are events that have been polled from the Kubernetes API server, and it's saying that the event message is back off, restarting failed container. It's telling me that the memory limits and CPU limits are okay. But now I can go down here and see something which is very, very powerful. And this is a timeline of the pod state metrics. So as I hover over here, I can see what the specific metric is and how it has been proceeding along the timeline. So this one is, the metric is pod container status waiting reason, and the reason is crash loop backoff. So we knew it was in a crash loop backoff state, but we can go along the timeline and I can see now that the metric has changed to pod container status ready. So the pod is started up and it's ready to go. And directly after that, I can see that we're looking at container status terminated. And the reason is OOM killed. Now, what is OOM killed? That is out of memory. So that is a decision that's been made by the Kubernetes scheduler. It said, don't have enough memory and you're on the chopping block. And without the metrics, that's not something I can easily see. So we can see there was an event that said it's backed off and it's restarting, but there's nothing telling me that it's been killed. So without those metrics, I'd be flying blind on this issue. Now we can scroll down here a little bit further and see if we can work out why this is happening. And yep, there we go. So within Kubernetes, when you have a deployment, you've got some request limits, and what these are is the amount of allocations that are made to a pod when they're started up. So the request limit is what it initially gets allocated, and then we also have the resource request is what it gets allocated when it starts up. The resource limit is the maximum that it gets. And in this case here, we can see that the container memory working set bytes, so the actual amount of memory it's using, has eclipsed the limit that is being configured. So people configure limits as guardrails. They don't want to use up all the memory on the cluster if something has a memory leak. But in this instance, the standard working amount for this particular container is eclipsing that limit, and it's being killed off by the scheduler. So that's something that I need to change my configuration on, but it's been quite quick for me to work this out. That's one of the key things is A, without the metrics, you're flying blind, and B, being able to quickly go from smoke being the red honeycomb to the fire, which is the actual issue that had been caused. So that's a sort of troubleshooting type issue that we can go through. I'll just jump back over to my slides for a second, and we'll talk a little bit about how we're actually able to get to that point, how the data actually comes in. So data collection with our Kubernetes app is actually a little bit different from how things have traditionally been done with Sumo. So if you're familiar with Sumo, you know that we've got our installed collectors and our hosted collectors. This doesn't actually use our installed collector. So as we mentioned before, Kubernetes is governed by the Cloud Native Computing Foundation. So we've actually gone with a completely Cloud Native Computing Foundation governed collection methodology. So everything that we're using here is an open source project governed within that same ecosystem. For logs, we are using FluentBit. Now, FluentBit came out of the FluentD project. It's a lightweight version. It's written in C, has less features, but it's very low memory footprint. And that actually runs as a daemon set within Kubernetes, which means that there is a pod pinned to each node, and that is grabbing all of the logs as they're written and pushing those forward to our enrichment pipeline. For events, we have written a Kubernetes Sumo Logic plugin for FluentD, and that polls the Kubernetes APIs and grabs all that information that we get from the APIs, the events, and forwards those down the pipeline as well. For metrics, we actually use a Prometheus operator. So Prometheus has fantastic auto discovery and auto instrumentation capabilities, very popular. Lots of people are using that to monitor Kubernetes. We didn't want to reinvent the wheel here. We've used Prometheus for what it's really good at, and we're sort of solving some of its scalability issues with our scalable metrics backend, but we're using it for what it's great at: auto discovery, auto instrumentation, and sending that down our enrichment pipeline as well. Security, as mentioned, we're using Falco. So Falco is a kernel level anomaly detection tool for security. And that's an optional part of the stack. You don't have to deploy Falco. If you're using other security tooling for containers, that's perfectly fine. If you're not doing anything at all, Falco provides you much more visibility than you would otherwise have had. Now, the enrichment pipeline, this is a FluentD deployment itself, and this is where the secret sauce is for us. So every single log event, metric, or security event gets tagged with service, deployment, namespace, in addition to the more traditional infrastructure level taggings of node, pod, and container. And that is what allows me to pivot between those different views. And it's what enables us to have this pivot between the infrastructure and the service view. So specifically, as we saw before, when I was in the node-centric view within Explore, there was no specific order to where my pods were. When I swapped to the namespace view, everything was ordered logically within the namespace. There is also a service view, which allows us to centralize on a service-centric viewpoint. So we go from something which is complex and disconnected from the customer reality and hard to find and troubleshoot issues to something which is simple to understand and is tightly connected to the customer reality, what you are putting out to the world. So I'll jump back over and we can see here that below the namespace view, I have my service view. Once again, it's ordered by namespace, but say if I want to have a look at what is going on with a particular service. So this is the Sumo Logic deployment. This is actually running the collection. So we can see here the bits I just spoke about, Fluent Bit, Fluent D, and Prometheus. If I want to have a look at the service for my Fluent Bit metrics, I click on the service and it shows me logically ordered in one place, even though they are spread across all of the different nodes, all of the related pods for that specific service. And I can see at a glance that they are all in a green state. Everything's running fine. My errors, this says no data to display, the little cactus. So that means that there's no errors. So that's the key that you want to see there, is that the cactus is a good thing, means that there's actually no problems. But that's the really, really powerful. If someone comes to you and says, I have a problem with my service, my payment service, my map service, because that's what they work on, that's the microservice they work on day to day, and you can go to their namespace and click on the name of the service and see everything that's related, that's hugely powerful. Because if you don't work in the DevOps team who manages the Kubernetes instance, if you're not sort of living that day in, day out, you may not know anything about how the container deployment actually works within your organization. You're a developer, you're working on something, but you've got a problem. You're going to tell them what you know, which is the service name. So having the ability to troubleshoot from that lens is hugely, hugely powerful. So I'll just pivot back for a moment. We'll go back to the namespace view and go through a bit of a different use case, because something that jumped out to me before when I was in this namespace was that we had two pods which had an issue. So we looked into the carbon black one because that one didn't have any errors and thought that was a little bit odd. So let's investigate what's going on here in the PagerDuty one. So I can actually go into the pod once again. And I can see that, yep, this one's in a crash loop back off as well. Lots and lots of restarts. And the pod events once again telling us that the restarting container has failed. We can go down the timeline I can see here that crash loop back off, container status ready, but we've got something a little bit different here, which is the reason for the termination. And in this case, the reason is error. So in this case, the metric is not helping us too much. The metric is just saying that there was an error. So this is not a useful, as useful way. And it sort of underpins the reason that we need a few different tools in our toolkit, a few different arrows in our quiver when it comes to troubleshooting, because it's definitely not those request resource limits that I had before. We're nowhere near the limits. So that's not what's causing me the grief here. I can go down, I can see what's going on, but yeah, there doesn't seem to be anything that's actually on a hardware issue that's going to be what I want to look into here. So what I can do in this sort of instance is, let's have a look at what is going on in the logs. So one of the great things about this is that everything has been built here within the Sumo platform. So this isn't a separate product that runs off to the side. This is all within Sumo. So I can absolutely say, show me all the logs. And for those of you who are familiar with Sumo, you might see something which is a little different here in that there was no source category. So this is actually using Kubernetes specific metadata, but a good thing to know is you're able to do this with all of your logs within Sumo. Now you can tag things directly with key value pairs at the collector level, which is really handy. So it's shown me specifically that it's the deployment is PagerDuty. The pod is the specific pod name, including these ephemeral strings that we get here, or the random strings due to the ephemeral pods, and the namespace. So I can see here, the first log sort of grabs my eye is the fact that we have a 401 status code. And that says to me that it is an authentication issue. So might just have a little bit of a look here and see if there's anything that jumps out to me. Okay, I can see there was an access key here in use, and I can also see an access ID. So what I might do is actually just grab this access ID, and let's just have a look over the last, say, 60 minutes, and I'm just going to look for this access ID within my logs. So that's one of the great things about Sumo is everything is indexed, so I can look very quickly and just say, show me everything. I don't want to look through all the particular instances of this, so I'm just going to use log reduce. This is our pattern matching algorithm, uses machine learning to cluster everything together, and rather than have pages and pages of logs to look through, it's just going to show me the signatures. So, okay. There was a bunch of things where it was just showing the final value for that, but I can also see that someone has actually deleted this access key. So it looks like someone from the SOC. So I can actually click on this here, go into the details, and okay, yep, I can see that someone deleted the access key there. Let's have a look at the surrounding messages here. Might see a bit of a story. So, okay, so users logged out, Kenneth, and this user's logged in, and he's actually deleted. So someone from the SOC has deleted this user, and he's disabled the access key and then deleted the access key. So it looks like we've got an issue where someone has left the organization and had their keys deleted, which is a standard process, something useful, but we've actually got a service still in use, being this PagerDuty, which was using that particular key. So that's a completely different sort of issue that can absolutely happen. It looks like we need to fix our process there, so we make sure that we check if a key is in use before someone is offboarded, but something that can very easily happen within an organization. But that is being able to go from what may be ostensibly shown as a Kubernetes issue, but it was actually more of a human resources issue, but we were able to target that very quickly and drill down into the logs to be able to get visibility into what's happening. And that's what's really powerful about having the logs and the metrics brought together within that unified view. Excuse me. So yeah, there's a couple of sort of key use cases, really powerful ways that you can explore into that Kubernetes data. So I'll jump back over to my slides for a second and talk a little bit more about the broader ecosystem. So the Explore view is something that we've developed within Sumo. We think it's very powerful. We think it's a great way to be able to logically explore what's going on within your Kubernetes environments. But we're only one part of this ecosystem. There's a whole heap of other great providers who are doing things around CI/CD, so continuous integration, continuous development, DevOps, SecOps, and we're actually partnering with these providers and integrating them into our Explore view. So Circle CI, CodeFresh, Armory, Harness, the major cloud providers. So whether you're running on, Amazon EKS, Google GKE, or Microsoft Azure AKS, everything looks the same. You might have a couple of different dashboards available to you depending on the service, but it is that same view. So even if you're in a multi-cloud environment, you have a consistent set of monitoring dashboards rather than getting lost when you move between one provider to the other. And on the SecOps side, as mentioned, we bundle in Falco, but there's also great companies like Twistlock, StackRox, Aqua, Tegera, JFrog X-Ray. If you're using any of these providers, you're able to get that data in as well and pivot through it in our Kubernetes Explorer. So for an example, if I jump up to the cluster level here, I can go to my cluster overview dashboard, and I can also go, so Cluster Explorer, see what's going on, relative heat maps for the usages of my pods. But we also have things like the security overview. So this is where we have what's going on with Falco. So the different events, which rules have been triggered, what's the severity of these errors, which users are triggering these, what priority. These are all things that we can alert on within Sumo. So these are all events that are here. So, but triggering rules that you want to, these are absolutely things you can alert on as well. Now, these are all been dashboards which are provided by Sumo out of the box. So we can see here other things which are specific. So AKS, if you're using AKS, what's going on with my API server? So this is something that is being managed for you by the cloud provider, but you can still monitor what's actually going on. But we also, as I mentioned, have a lot of different applications which are provided by our partners. So if you're using Twistlock for your vulnerability scanning for containers, you can actually see this data within the same environment. So you can click on a specific cluster and see, a roll up of what's going on. So how many hosts have we got? How many containers? What's critical CVEs do I have? Which fixes are available? And this is all data that's available to you within this same platform. So great tooling, but also being able to see this at a glance within the same platform. You're not going through 14 different web portals. It's all available to access directly. Really handy. So you can see here within our app catalog, you can go to the Kubernetes section, and yep, so the different providers. So even things like service meshes, if you're using Istio as a service mesh, that's available there as well. Provides dashboards to you within that Explore view. And that's just something that we find, well, I think is really great. And it's really nice to see here the partner provided. So the little ticks here, this means that that actual sort of technology partner has built that app out because they think it's useful, it's valuable for people to be able to see that data within Sumo directly. So look, that's the core of what I wanted to take you through today. I hope you found it interesting or informative. If there's anything else that you would like to know, please fire away in the Q&A. We've got a little bit of time left, so I'm happy to answer some questions if you've got anything that you would like me to dig into. If there's something you would like to try, if you're new to Sumo and you haven't tried it out before, please jump on our website, go to sumologic.com/sign-up, or just click on the sign-up link. We've got a free trial, so you can actually, few minutes, jump in. We're a SaaS platform. There's nothing to set up on the back end, so you can actually get it up and running and play with it yourself. And it's, yeah, the full version. If you would like to talk to us more, we've got a public Slack channel, so you can go to slack.sumologic.com. I'm there, a bunch of the other engineers are there. You can actually ask us questions, and it's much nicer than sending emails to people. I would thank you very much for your time, and I hope to speak to you later. Thanks very much.